Okay, so here we have the introduction to our unit on light and physical optics. This is a quick review, a very quick review of wave theory. We would have touched upon this in grade 11 a little bit, and so we're just going to go over it really quickly, just so that you have some of those terms just right at your fingertips, and we take a second to review them. Waves, of course, carry energy from one location to another via some type of disturbance. There's several different types of waves. Transverse waves, longitudinal waves, and torsional waves are a few examples. Light is a transverse wave. Sound is a longitudinal wave. So here's an example of a transverse wave. We have the motion of the particles, which is, of course, at right angles to the speed of the wave, or to the movement of the wave. And that's why it's called transverse, because these are at 90 degrees. We got the wave motion up and down, particle motion like this, and then we got the direction or the speed of the wave that is perpendicular to that. Longitudinal is a little bit different. This classically demonstrated by a pulse that goes up and down a spring. And of course, the motion of the pieces of spring are in line, parallel to, not perpendicular, but parallel to the speed of the wave. Waves can be considered pulses, or they can be periodic, right? So their motion will repeat itself at a known interval. Any repeated motion is called periodic motion or harmonic motion. So here's a couple terms that we just need to know. The period for any wave is the time to complete one cycle. Okay, so from one position to its return position, and this is kind of the periodicity of the wave, and it's the time to complete 1 second. In physics, usually we give it the symbol capital T, and it's measured in seconds. Okay, so we've seen this before. It's come up in our fields unit, and it's come up in uniform circular motion, but here we have it again in terms of waves. Frequency is not the time to complete one cycle, but the number of cycles per unit time. Usually we give it this a curly F, and this is measured in hertz. Now hertz is just seconds to the -1, right? So it's the inverse of period. Frequency and period are inverse of each other, okay? And so hertz is a derived unit. It just means 1 over seconds, so seconds to the -1. Wavelength is the length of a wave, okay? It's got a symbol lambda, and this is measured in meters. So it's the distance from where the wave starts to where the wave stops, or where it would begin to repeat itself again, and that's the wavelength. The amplitude is the maximum displacement of any particle. So if you consider a transverse wave, you would have the maximum displacement from the zero line up to a crest, or from the zero line down to a trough, and that would be the amplitude. And phase shift, which is something that you've talked about in mathematics courses. Amplitude, usually we give it the symbol A, and it has, well, really it could be measured in meters, but really the amplitude is whatever you're graphing on the y-axis. That's the units that it's going to have. So in this case, maybe it'll be meters. In another case, maybe it'll be something different. Phase shift is the relative position of a wave compared to the standard representation. So we know that a sine wave and a cosine wave are phase shifted with respect to each other, and they're phase shifted by 180 degrees. We have lots more, they're phase shifted by 90 degrees. That's more accurate. The relative position of a wave compared to the standard representation. And so this becomes very, very important when we talk about interference, and we're going to talk about interference in this unit. Phi is usually the symbol that we give to the phase shift. It can have other representations as well, but we're going to stick to phi. This type of motion can be represented by a sine or a cosine function. It's called simple harmonic motion. And most of the time, simple harmonic motion, if we're going in the y direction, we say we've got some oscillation in y. We use sine. and if we're going in the x direction, we use cos. This is just really by convention because we know that these two things are just phase shifted. And we will look at simple harmonic motion much more when we investigate AP Physics, if you're taking that. All right, a couple examples. Calculate the period and the frequency of a plane's propeller if it completes 250 cycles in 5 seconds. So, of course, we know that frequency is cycles per second. So in this case, we have 250, and we're going to divide by 5, and we get 50 hertz is the answer that we're looking for. Period is, of course, 1 divided by frequency, so it's the inverse. This is how many seconds it takes to go around once. And we get 1 over 50, which when we do this math is 0.02 seconds for that propeller to complete 1 full cycle. And there we have it. Example 2, use the diagram of the periodic wave below, which here it is. I think it's already in your notes. Find the amplitude, the wavelength, the frequency, and the velocity. So first of all, the amplitude of this wave, we're going to solve by inspection. And we can basically take the wavelength and solve that by inspection as well. But here, because we start at 0, and we go to a maximum of 2, and then back to 0, and we go to a minimum of -2, the amplitude is 2 meters. And we just solve that by inspection. The period in this case, because the x-axis is not a time axis, it's a measured in meters, so this is actually going to tell us the wavelength. But here, this actually tells us that the period for this is 0.005 seconds to complete a cycle. And the frequency then is 1 divided by the period, so we get 1 divided by 0.005, which is 200 hertz. The wavelength is 4 meters from the beginning of one wave to the end of that wave, and of course then this would repeat. The wavelength is 4 meters. And we can now solve using this, the universal wave equation. V is equal to F lambda, 200 times 4, and we get that this wave would be moving at 800 meters per second. All right, so there's the speed of the wave, and that's your little review of wave mechanics. On to lesson number 1B, electromagnetic waves.